This video covers water hardness. So, what causes water hardness? Well, the hardness of water is caused by the presence of calcium ions and magnesium ions. How do these ions become present in water, you may ask? Well, it happens when water comes into contact with limestone and other calcium-containing rocks. How can temporary water hardness be removed? Well, a method of removing temporary hardness is to boil the water. This method results in a layer of limescale, which coats the heating element of appliances such as kettles, as shown on the screen. This causes the efficiency of these appliances to lessen. Limescale is also an issue because it's unpleasant to look at and clogs boilers and water pipes. During this process of boiling, soluble calcium hydrogen carbonate is broken down into insoluble calcium carbonate, water, and carbon dioxide. Now, pause the video and see if you can figure out what the equation is for this process. Here's the equation, and congratulations if you had it right. Now, we've talked about how temporary hardness is removed. Now let's talk about how it occurs in the first place. Rainwater is naturally acidic, as the carbon dioxide in the air is dissolved in rainwater. This then reacts with the rocks containing calcium carbonate to form soluble calcium hydrogen carbonate. It is the calcium hydrogen carbonate formed which causes the temporary hardness in water. Now, as you can see from the equations, the process of removing temporary hardness is the reverse of the formation of temporary hard water. So, we've talked about temporary hardness. Now let's talk about permanent hardness. Permanent hardness is caused by dissolved calcium sulfate. And unfortunately, unlike temporary hard water, boiling cannot remove the hardness, as it is caused by calcium sulfate, which is not broken down by heat. Now let's talk about the good and bad sides of hard water. The advantages of hard water are that it aids in the reduction of heart disease. Its taste is preferred by some people. The teeth and bones of children are strengthened. And hard water is preferred to some bakers and brewers. However, disadvantages of hard water include that it causes difficulty in forming soap lather. Limescale formation slows heat transfer. Appliances such as dishwashers, kettles, washing machines, making them less efficient. Soap is wasted due to the formation of scum. And hot water pipes can become blocked as they fill up. Many methods can be used to soften water. In this video, we're going to talk about distillation, washing soda, and ion exchange columns, with a closer look at washing soda and ion exchange columns. Distillation can be used to soften water, as it can be used to separate the ions from water by the evaporation of water, leaving the ions behind. Distillation is also used to separate and collect liquids from a solution. Washing soda is another name for sodium carbonate, Na2CO3. It can be used to soften both permanent and temporary hard water. An advantage of using washing soda is that it's inexpensive. A disadvantage, however, is that narrow water pipes can become blocked due to the formation of limescale. Now on to content for the higher T students regarding washing soda. Sodium carbonate, or washing soda, is soluble in water. When dissolved in water, it introduces a lot of carbonate ions, which can react with the calcium ions in hard water, causing calcium carbonate to precipitate out. Now, pause the video and see if you can figure out the equation for formation of calcium carbonate. Here's the equation, and congratulations if you got it right. Another method of softening hard water is using an ion exchange column. As with using washing soda, ion exchange columns soften both permanent and temporary hard water. Calcium and magnesium ions, the ions which cause water hardness, are removed as hard water is continually passed through the column. An advantage of using the ion exchange column is that it does not need to be replaced as washing soda, making it a more convenient method. A disadvantage, however, is that ion exchange columns are expensive. Now, on to the content for higher tier. The tube or column is packed with resin balls which have a diameter of 1 to 2 millimeters. The resin balls in the ion exchange column start with sodium ions attached to them. The sodium ions come off the resin and enter the water as hard water passes through. While this is happening, calcium ions are removed from the water and attached to the resin balls. Effectively, sodium ions which do not cause hardness are switched for calcium ions which do cause water hardness. Dishwashers are an appliance which features an ion exchange column to soften water. When the sodium ions of the resin have been completely replaced with calcium ions, the resin needs to be recharged with dishwasher salt or sodium chloride.